Hi. Okay. I can hear myself now. Hi, everyone. Welcome to this presentation. My name is Marcelo. I've been working with Aurora since a long time now, and before I was an engineer at Near Protocol. Today, I wanted to introduce a quite technical feature we have been working recently in Aurora. But before I actually dive into what is it about, let me give you a brief introduction about what Aurora is. Are you here familiar with Near Protocol? To some extent, okay. I see 1, 2 hands. Okay, you are familiar with Near Protocol, so let me give you a brief introduction for those who are not. Near Protocol, it's a layer 1 blockchain, very similar in concept to what Ethereum is, but it strives to, learn from previous success and failures of Ethereum, and it tries to drive a usable and scalable blockchain. Usable meaning where end users and developers can work on top of Near easily, and scalable meaning that it will provide a real horizontal scaling, meaning it doesn't need to be centralized to be able to process more transactions per second, so no security sacrifice. Near comes with a built-in runtime that allows having these usability and scalability features, but this runtime is based on WASM, WebAssembly. This is a new standard that it's been designed for the web and to be executed natively on several architectures. So most of the developers, of the blockchain developers in the space today, they basically are learning to develop on top of Ethereum, which is basically a EVM-based blockchain. EVM is like the virtual machine that you can use on Ethereum, meaning that most of the developers, what they are learning today, it's Solidity. If you are somehow familiar with that, I guess you will know what I mean. So basically, there is a disconnection between new blockchain developers, which are in high demand these days, and what Near it's supporting natively. So here is where Aurora comes in. Aurora tries to bridge this gap. Aurora is an application on top of Near Protocol where you can develop smart contracts in, let's say in this case, in Solidity, but basically any other language that will compile to EVM. So you can deploy and execute EVM bytecode on top of Aurora, while Aurora is just a smart contract on top of Near. It's a little bit mind-blowing, the concept of Aurora in itself, in the sense that it's like Inception. It's like a blockchain inside a blockchain, where Aurora blockchain itself is completely developed as a single smart contract. It's just an interpreter of EVM deployed on Near that you can use. So that's what is it about Aurora? So new developers can work on Near. New Solidity developers can work on Near by deploying their contracts on Aurora. So far, Aurora has developed its own ecosystem. We have been heavily focused also in usability. This is what I want to introduce to just briefly mention about Aurora Plus, which is the platform that we're creating to onboard new users, because the peculiarities of how Aurora works, that it's used interpreted on top of Near, there is actually no need to pay, the gas doesn't need to be paid in ETH, like all transactions that you execute in Aurora, you pay the gas in ETH, but actually what's happening in the background is that there is executing a Near transaction where you pay the gas with Near. So basically we have an infrastructure that will that will charge the gas in ETH and will pay the required Near. What we're providing with Aurora Plus is an interface where users doesn't need to pay any sort of gas at all. So basically they can just jump into Aurora. You can go to Aurora.plus, you can register there, and then you will have like 50 free transactions per month, and after that you will have subsidized transactions. And there are plans in the future to onboard users even easier, so they can, like the whole point of paying transactions is not to make any profit out of it, but to prevent spam. during a long period of time, Aurora was completely free. We needed to change that when a few games were deployed on top of Aurora that went over the capacity of what our network could handle at that moment. So a very small fee was introduced. But at the same time, this small fee, it's really disruptive for new users that doesn't want to know anything about the blockchain. They want to use the application that they are presented to. So this is the whole goal of Aurora Plus. So until this moment, Aurora has its own ecosystem. So a lot of developers, mostly developers coming from Ethereum ecosystem, but from other EVM-based blockchain as well, have been deploying their contracts on Aurora and interacting between each other. But this is, we want to expand this. Right now, we know that the present, more than the future, is actually cross-chain. And in this particular case, we have a special benefit about interacting with near smart contracts, because there is no bridge required to interact between Aurora and Near, given that Aurora is just a smart contract on top of Near protocol. So the whole, what we want to achieve is to connect applications deployed on top of Aurora. We want to be able to connect them with Near. This will allow, so this is, first, before diving into that, wanted to share some of the goals that we have. Basically, at this point, our team is focused on scaling Aurora, right? Going beyond its current capabilities. We have been heavily focused for the last months on how to scale Aurora vertically. This meaning that we want to be able to execute transactions faster, cheaply, to be able to fit enough gas in a single transaction such that we are able to execute whatever would run on Ethereum. Notice that for example, Ethereum blocks are generating every 13 seconds. So in this 13 seconds timestamp, like a time frame, Aurora it's able to handle more like TPS than Ethereum currently, but in Aurora, in Near, blocks are generated 1 per second. So we are limited to what a machine can execute in a single second, right? So in some cases, definitely it's not enough. Like some transactions that can be executed on Ethereum in a 15 seconds time frame cannot be executed in Aurora in 1 second time frame. But we have been doing some experiments and have found that our interpreter is not efficient enough. It's definitely not easy to make it faster, but that's one of our current focus. We have been also working with Near runtime team, and there is a new application we have been working. This is actually very recent. It was presented 1 week ago in NearCon, which is a compiler from, you could say a transpiler, sort of compiler from EVM to WASM. So whatever code you generate in EVM, we will compile it to WASM. The resulting bytecode will be more efficient and could be executed natively on Near protocol. But here it's there is a very hard limits on how far we can get using this type of scalability. So the whole point of Near scalability is sharding. This is what allows Near to scale horizontally by sharding the computation and the state that each validator needs to have. In the particular case of Aurora, it's not trivially getting benefited from sharding, in the sense that Aurora is a smart contract that will live in a single shard. So by adding more shards doesn't mean that Aurora will get any benefit, because it will have the top of what a single shard on Near can execute. So one of the visions that we are currently exploring, it's deploying Aurora on multiple shards. So basically, if Near grows horizontally, Aurora could grow horizontally as well. But there is some major caveat to that, is that one of the main characteristics of Ethereum, which is we take it for granted, it's that the whole execution in Ethereum is synchronous, meaning that you can make a bunch of transactions, a bunch of calls between smart contracts, and you know that if something fails, like either all the transaction is successfully executed or all the transaction fails, but there is no like point at which something is executed successfully, but after that it stops. This is, for example, what allows flash loans to work the way they work today. Basically, I can get any arbitrary amount of money from as a loan. I can execute my code, and then at the end of the transaction, I need to be able to repay the loan all in a single block. Well, this is not exactly the case of how it works on NEAR protocol. On NEAR, we have a synchronous environment. Main reason for that is that since the whole concept of NEAR is to be sharded, which it's actually partially sharded today, means that code can be executed in multiple blocks by different machines. So it's possible that we have partial executions, and then future executions are not happening due to gas problems or any kind of problems coming from asynchronous execution. So Aurora on itself provides synchronous environment for contract execution. But if we go, if we do a horizontal, if we deploy multiple Auroras, they need to use the asynchronous NEAR environment. So what I wanted to talk today, just get to the point, it's a new mechanism for allowing communication between Aurora smart contracts and other NEAR smart contracts. In particular, it could be in the future other instances of Aurora smart contracts on NEAR protocol. Let me describe how this mechanism will be about, and then later if you have any questions, I'll be here or I'll be around for answering any of them in case you are interested. I'll go quickly over this image because I have a diagram later that I think it's better. The whole point is that if you are somehow familiar with the development on Ethereum or Aurora, we are creating a new precompile. So Aurora strives to be backwards compatible, fully compatible with Ethereum, but in some particular cases we have been extending Ethereum capabilities when it makes sense in the context of Aurora. So this new precompile will allow to start a new cross-contract call. It's basically like an entry point or an exit point to go to the whole NEAR ecosystem. For every address that exists today on Aurora, there will be a new account ID created on NEAR that will be executing the calls on your behalf. And anyone will be able to use this kind of feature in a trustless and decentralized way. So there is users are free to go over this feature. This is a brief diagram about how it works. Basically, we have a user interacting with Aurora contract on NEAR. You can see this triangle as the Aurora contract NEAR. In particular, they will be interacting with this smart contract inside of Aurora that I'm calling 0xBIF. This contract wants to do a transaction where it interacts with berryclub.near. This is just as an example contract on NEAR. It's a platform where you can paint, similar to the place on Reddit if you have heard about it. So we have 0x.bif that wants to make that 0xBIF user or application wants to interact with berryclub.near. What it does is it calls cross-contract call precompile, which we have been designed with proper arguments. Basically, it needs to specify which is the contract that it's targeting, what are the method and arguments. And then the cross-contract precompile will be in charge of making sure that this cross-contract call is executed. Notice that 0xBIF is potentially a smart contract on Aurora that's coded in Solidity. It calls this precompile, and then at the engine, that's how we call the Aurora contract. The engine, it will be able to oversee all calls to this precompile, and it will schedule the relevant cross-contract calls. In this particular case, first thing that the Aurora contract will do is create 0xBIF.Aurora on NEAR. It will create this account, and this will work sort of as a factory, in the sense that Aurora will be creating one of these accounts per Aurora address. It will be do that on demand, not that we're planning to do this with every other address out there. So this account is created on near, and the cross-contract call to veryclub.near is routed through zeroackbeef.aurora. Main point of going through this intermediate step of zeroackbeef.aurora is that we need a way to authenticate on veryclub.near, which is the sender. That's a critical part when you are doing cross-contract calls. You need to know who is sending you this information. If we were to execute this transaction directly from Aurora to veryclub.near, there is like veryclub.near won't be able to tell apart different users in the Aurora ecosystem. That's the whole point. But no one will be able to interact with zeroackbeef.aurora, which is not the Aurora contract itself. So let me go quickly through some of the applications that this feature will enable in the Aurora and Near ecosystem. I think one of the most critical features it will enable is that not only there are too many developers on the Ethereum ecosystem, or I mean, not too many. There are definitely too little. We need more developers, but I mean, most of the developers are in the Ethereum ecosystem, but also most of the users, blockchain users, are some way or another in the Ethereum ecosystem as well. So they are used to the tooling that we present to them. In particular, for example, MetaMask is one such tool that we use as well in Aurora, given we are EVM compatible. Having this cross-contract call communication will allow users, Aurora users, MetaMask users that are used to interact with Aurora, to interact with other near contracts still using MetaMask. So they will use their own address, their own wallet that they have on Aurora to start transactions on Aurora that will be later on executed on Near. So that's a really neat feature that it's certainly not possible today. There have been some efforts to use MetaMask on Near in a different way, but requires some setup from part of the users. This is basically like a zero cost abstraction for users to start using MetaMask on Near. One other such case, it's like become a DAO member. Like on Near, we have these DAO contracts where single account IDs can become members of the DAO. Previously, Aurora addresses couldn't be part of a DAO as itself, since they have no representative account on Near protocol. They needed to create their own account on Near protocol. Right now, it will be possible for them to interact with a DAO and, for example, also own an NFT from your Aurora address. For the developer applications, some of the examples is that this is something we are actively working right now. Aurora native RC20 tokens will be able to be moved to Near, no bridge required, just a connector that will be using this cross-contract call communication protocol. So you will be able to move your RC20 tokens that were deployed initially on Aurora. You'll be able to move them to Near, back and forth, and eventually, if a connector from fungible token is created within Near and other platforms, well, you'll be able to move them as well. One very neat application is that if you are somehow familiar with 1inch, 1inch it's an aggregator protocol that will look at several DeFi, several DEXs, and will try to make a swap as efficient as possible in terms of profit through several DEXs. Right now, similar application exists both in Aurora and Near, but right now it's possible to have an application that will look in DEXs that exist in Near and Aurora at the same time. So in a single Near transaction, they will be able to swap through multiple DEXs in both ecosystem, sort of atomically, like no bridge required. So that was it. We definitely have much more time in case you have any questions. Otherwise, thank you for your participation.